Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to actually write the volume populator that we have been talking about. So in the very first video of this series, we just talked about data source and data source ref field of the PVC resource. In the second video of the series, we actually talked about the overall architecture of the volume populators. And in this particular video, we are actually going to write the volume populator from scratch. We are going to discuss about which particular volume populator we are going to write, and then we are going to actually write that. So let's just go ahead and try to start from the very start. So let's name our project uh, generic HTTP populator, and we are going to talk about in just a second what this populator is going to do. So generic HTTP populator and cd into this particular project, and let's open this in our text editor. So after opening the project in the text editor, let's talk about what exactly are we going to write and how are we going to write that. So we know that volume populators are a way using which you can populate the new volumes that you are going to create dynamically, and we have already talked about all these things in previous videos, so I'm assuming you know about these things. So we create a new volume, we provision a new volume on a Kubernetes cluster by creating a PVC resource. So let's just go ahead and try to create that PVC resource so that I can share what exactly our populator is going to do. So I'm going to create a file called pvc.yaml, and this particular file, if I open, let's take an example of this particular PVC resource here. This is Kubernetes official documentation. I can link that in the description if you want to. So if I just create this particular resource here, and our Kubernetes cluster is set up in such a way that it supports dynamic provisioning, you would have a volume with this particular capacity created, and that would be consumable by your workloads. But again, I have talked about this in previous videos, but just to summarize, in case of volume populators, what we try to do is we our use case is to provision a volume, and that particular volume should be populated with some data. So as soon as I get the volume to be used by our workloads, it should have some data in it, and that is the use case of volume populators. So that is what we are going to do in this particular video, and that is achieved using data source ref field. So let's just go ahead and try to look into how we can specify data source ref here. So we are going to specify data source ref, and under data source ref we are going to specify an instance of our volume populator. And what exactly this volume populator in our case going to do is, as the name suggests, it's going to, our volume populator is actually going to populate a particular persistent volume claim, or to populate a particular PVC with whatever content there is on a particular URL, let's say, or on a particular HTTP endpoint. So let's say I have a particular HTTP endpoint called, let's say any readme. I'm going to open one of my projects. So let's say this is the project, and let's talk about any source file. Let's talk about readme.md, and if I want to create a particular volume, a PVC, and that PVC should already be, or should be populated with the content of this particular readme.md file, this is the populator that we are going to write today. Now here is the thing, it's called generic HTTP populator because it is supposed to create the volume, or it is supposed to populate the volume with any HTTP endpoint, let's say. So it's not just limited to this particular readme.md. You can even specify this particular URL, and your volume is going to be provisioned with the content of this particular URL. So this is what we are going to develop today. Again, if I try to summarize the populator that we are going to write today, this populator can be used to populate your volume with the content of an HTTP URL, let's say. And these are some of the examples that I talked about. For example, this is content of this particular URL. So if you create a volume populator instance specifying this particular URL, and then you refer that volume populator instance under dataSourceRef field, in that particular case, this particular PVC must have the content of that URL that is configured in the volume populator instance. I hope that makes sense. So if we look into the fields of dataSourceRef field here, if we go to how dataSourceRef field looks like, so this is of typed object reference, and typed object reference is actually API group, name and kind. We are not going to talk about namespace for now because we are assuming that the volume populator instance that we are going to refer using these fields and the PVC where we are referring the volume populator from are in the same namespace. So eventually this is what we are going to do. So API group and then kind and name. So, and this is reference. Again, I would like to highlight it once again. This is reference to a volume populator instance. So I have talked about it already. We are going to create a CRD that would be our volume populator, and then an instance of that CRD, and we are going to refer that instance from here, and we are going to decide all those things in just a second. So now let's talk about how exactly our CRD should look like. So if someone wants to create a persistent volume claim using our volume populator, first of all we will have to provide them with a CRD that can be used to introduce our volume populator. So first step is going to be create CRD, and second step is going to be create an instance of CRD. So this is what user is going to do, and then user is actually going to refer to this instance under pvc.spec.dataSourceRef. So now, I mean, you might have noticed that the only thing that we need from user, or the only thing that our populator needs from user is the URL from which we want to get the data and write the data into the PVC. So let's just go ahead and try to write the CRD. So I'm going to call it GenericHTTPPopulator -crd.yaml, and again let's go ahead and try to get the CRD example from Kubernetes docs. So this is the CRD. This is the example CRD manifest that we are going to create in order to make sure that Kubernetes cluster knows about the new resource that we are introducing. I have made videos about custom resource definition, so you can watch them. So we are going to introduce this resource under k8s.viveksingh.dev, and the version is going to be v1 alpha 1, and this is the version that is going to be stored and served. And the spec is, if you see here, this is how we specify how the spec of the CR is going to look like. So in this particular case, we don't exactly need all these things. We just need URI, let's say, and the type of this particular field is going to be a string. And this is all we need from the user. to be able to pull the content from this particular URI and write that to the volume to populate the volume with. This particular resource is going to be namespaced, and plural is going to be, let's say, generic HTTP populators, and singular is going to be generic HTTP populator. Kind is going to be generic HTTP populator, and short name, let's say GHP. Again, it's expected that you know a little bit about kind and resources that I'm not going to talk about in this particular video. But yeah, I mean, you might have this question: why do we have everything in small cases here, but in camel cases here, and things like that? So yeah, I mean, I'm gonna say that it's let's say expected that you know about these things. So our CRD is almost ready, I would say. So generic HTTP populators dot K8S dot viveksingh.dev. So now that the CRD is ready, what we can do is we can create an instance of the CRD, and we can refer that instance in this particular dataSourceRef field. And after that, we can say that, okay, now we have a volume populator resource at least, and that resource can be referred in here, that is dataSourceRef. So let's go ahead and try to create a new YAML file that is going to be instance of that CRD, and let's call it access readme populator.yaml, and we are calling it access readme populator because we are going to use this particular URL to generate the data, the readme of access project. So let's go ahead and try to create API version, and we know that API version is going to be group. So K8S.viveksingh.dev, and version. So version is v1 alpha 1. Kind is we can copy the kind from here. So kind is generic HTTP populator, and spec is just going to have a field called URI, because that is what we need and that is what we have specified in our CRD. So URI in this particular case is going to be let's say this particular URI. Okay, so now if everything goes fine eventually, what should happen is if we refer this particular instance of the populator, in that particular case our volume should get created and it should have the content of this particular readme file. So let's go ahead and try to refer that from here. So API group is going to be K8S.viveksingh.dev, kind is going to be generic HTTP populator, and name is going to be name of this resource. And let's name it readme or access-readme-populated. Alright, so here is the thing. One thing that I would like to highlight is this is how we are going to use a populator, let's say. So right now, if we create this PVC, and we are going to see that very soon, if we create this PVC, it's not going to have the data of this particular readme. If you remember, we still have to actually write a controller that is going to listen for creation of PVC events, creation events of PVC resources, and then it's going to figure out that this particular kind is referred in the dataSourceRef, and then that controller is actually going to do everything. And since we have not written that controller, nothing is going to happen for now. So I just wanted to make sure that you understand how this new CRD that we are going to introduce and an instance of that CRD is related to the PVC resource. So that is what I wanted to highlight here. Now, I would also like to very briefly talk about the data source validator that we talked about, because data source ref fields would not accept invalid data source refs, invalid inputs. So let's go ahead and try to create a data source validator, and this data source validator would actually tell us if the details that have been specified under data source ref are actually valid or not. And this data source validator is again already written project that we just have to deploy. We don't actually have to develop the validator. And this validator needs the volume populator resources. So I already have a 3-node Kubernetes cluster, and if I get all the CRDs from this particular cluster, if you see here, we don't have volume populators here. We don't have volume populators, but the data source validator component that we are going to install, that is going to tell us if the details, if the resource that is specified under data source ref is valid or not, requires volume populator CRD to be present, let's say. That is the reason we are going to first install volume populator CRD, and then we are going to install the data source validator. So let's go ahead. I think I have already opened the document here, and this installs the volume populator CRD. So if I just open this URL here, it's just a CRD. If you see here, this is a CRD that introduces a resource or a kind called volume populator under populator.storage.k8s.io group. So it's nothing more than that. It's just a CRD. So let's go ahead and try to create this. So the CRD has been created successfully now, and let's go ahead and create the validator now. So to make sure that the validator runs successfully, it needs some RBAC, and this created that RBAC, those RBAC resources, and this command actually installs the data source validator, and it creates a pod in kube system namespace. So if we go ahead and look into the pods from kube system namespace, you should be able to see volume data source validator that was just created 11 seconds ago. So now that we have data source validator, let's go ahead and try to create this PVC, and let's see what our validator says about this particular populator that we have used here. So I am going to open another terminal here, and I'm going to look into the logs of that validator pod that we just have created. So cube-system, and then so now let's go ahead and create the PVC. So create -f manifests and then pvc.yaml. But first of all, let's go ahead and we will have to create this CRD and CR. So let's go ahead and do that. So create -f manifests and then our CRD, volume populator CRD. So CRD has been created. Not really. Generic HTTP populators. There seems to be a problem here. So it looks like there is a typo. Generic. There is a typo here. So it should be plural. Names dot plural. That is generic HTTP populator. Okay, I have a typo here as well. Okay, now it looks good. Now it should be created. So let's go ahead and try to create the CRD once again. And if you see here, CRD has been created now, and let's go ahead and try to create an instance of that CRD. So access readme populator.yaml. Everything is going to get created in the default namespace. So that instance has been created, and now we are going to create the PVC that is referring to an instance of that CRD under dataSourceRef field. So manifests and PVC. If you see here, now the validator was able to figure out that a PVC was created with the dataSourceRef field, and it says that, if you see here, it says that warning, unrecognized data source kind, the data source for this PVC does not match any registered volume populated. So it simply says that the data source that we have specified here does not match any there is no volume populator that is registered that has this particular data source that serves that particular data source. So, but here is the thing: you don't have to look into the validator log. If you describe the PVC, you should be able to get these details. So, if you describe the PVC, if you see here, it should say that. If you see here, the data source for this PVC does not match any registered volume populator. So if you look into the PVC is in pending state, and we have already talked about it. When you even when we write the controller, initially the PVC would be stuck in pending state. And if you describe the PVC, you would be able to understand that there is a data source ref field specified in the PVC, but respective populator is not actually registered. And again, if you remember from our last video, to actually register our populator, we will have to create a resource of type volume populator. So if you remember, we created a CRD that introduces the resource called volume populator. Now we are going to create a volume populator resource that is going to make sure that the volume populator that we are specifying here is recognized to be a valid volume populator. So again, let me have a look into that CRD. So this is the CRD, and the resource is under this particular group and version, and let's call it metadata. Name is going to be, let's say, generic HTTP populator -registrar, or let's just call it GHP. And under spec, if you look into the CRD again, the spec is going to be source kind. It's just the source kind. So source kind, and source kind has group and kind. So group and kind, and we know that the group of our populator is K8S.vxing.dev, and kind is generic HTTP populator. So now this is how we basically create a resource of type populator.storage.k8s.io. And the kind is going to be, so this is how we create a resource of type volume populator, specifying that this particular volume populator is a valid volume populator. So let's go ahead and try to create this resource. So create -f manifests, but first of all, let's delete the PVC that we created. So manifests and pvc.yaml, and now let's go ahead and try to create the volume populator resource. So volume populator, and okay, so it doesn't have spec. So this is how it should be created. So create -f manifests Okay, all right, we have a typo here in the name as well that we are going to fix in a second. So manifests and volume populator.yaml. If you see here, volume populator has been created now. So get volume populator, and we can see that we have specified the correct kind. And now if I go ahead and create the PVC, create -f PVC and then pvc.yaml, at least validator should not complain. So if you see here, now we see that allowing generic HTTP populator due to GHP populator. So GHP is the populator name that we just created that basically registers our volume populator with the controller. And we should not see that event in the PVC anymore. So kubectl get PVC would still be in pending state, but we should not see that event that the populator is not registered. And if you see here, we do not see that event anymore. But the PVC is still in pending state, and that is the most important point. So now what needs to be done is, so now we have registered our volume populator. If I try to, let's say, explain it via diagram, this is what should happen now. So now we should write a controller, and this is, let's say, the controller that we are going to write, and this controller is actually going to listen for the PVC resources. So this is the PVC resource that we just created right now, let's say, and this controller would get created, and this controller would be notified, and this controller should be able to, again, I have talked about it already. This controller is going to create a PVC resource again. This PVC resource here is in pending state. It would remain in pending state like we have seen here. If you see here, this is in pending state, and this is our default namespace. This is default namespace, and let's say this is controller namespace where we have controller running. This controller should be able to would create a new PVC. This would be bound to a new PV or volume, let's say, and then this controller is going to create a new pod, and this pod is going to write the data into this PVC, and this pod is actually the populator pod that we have been talking about. And once this populator has written data into this PVC, this volume would eventually have that data, and then this controller should remove this connection, let's say, should remove this claim, and this particular PV would be bound to this PVC eventually. So now eventually this PVC would have the data that this populator wrote. So now this is what we are exactly going to do. So let's go ahead and try or start writing this controller. And here is the thing, we also talked about there is a utility that is already provided by Kubernetes community called populator API machinery that basically helps us to do almost all of these things. So that utility can be used to make sure that we have a controller running. That controller is going to listen for PVC resources. It's going to create a new PVC with the same spec that has been specified here, and it's also going to create this particular populator pod for us. And we just have to write the logic to write the data into the PVC. Rest of the things are going to be taken care by this populator that I'm talking about. So let's go ahead and create a new file here called main.go, and this is going to be in package main, and let's create a function called funcMain. Now if we talk about this particular resource here, to call this particular controller, we actually need, I think 3 things here, and those 3 things are, first of all, this controller is going to create this populator. So this populator pod, and pod eventually needs an image. So we need, while running this controller, we need to specify which particular image should be run as populator. So we are going to, let's say, specify a field here, and we are going to get it using flag. So flag dot string var, and image, and name is going to be image, and default value is going to be empty, and usage is going to be image for populated component, let's say, or pod, to make it more understandable. Flag dot parse, to make sure that we can use these variables. Apart from image, it also needs to know where exactly this particular populator pod should get created, which particular namespace this populator pod should get created in. So we are also going to specify var namespace, and this is also going to be a string, and flag dot string var namespace, and then namespace for populated pod, or not pod, let's write component here. Apart from that, if you remember, we also talked about, now these two components, controller and populator, can be written separately. They can be two different container images, two different Go projects, two different applications, but they can also be single application, and we can run them in different modes. So that is what we are going to do. We are going to just have one binary, one application that is going to run in different modes. So we can either run, when we are running controller, the binary is going to run in controller mode, but when we run it as populator, we are going to run it in populator mode. So we can expect that as well. So mode is going to be string, and flag dot string var ampersand mode. Name is going to be, name of this flag is going to be mode, and usage is going to be mode to run the application in. I think these are some of the most important things that we actually need for controller to run. And like I said, we don't actually have to write the controller. We can just use this utility to run the controller. So here, if, or let's say switch, if mode is controller, in that case we have to run the controller, and if mode is populator, in that particular case we have to basically just we have to populate the data. So populate the data. And if it's neither controller nor populator, in that case we should just either we can log or we can panic as well. So println mode %s is not supported. Okay. So now let's go ahead and try to use this library that I have been talking about, and this is the library. So Kubernetes CSI is the org name, lib volume populator is the repo name. So lib volume populator and then populator machinery. So this is the library that is the main important or most important piece of this entire component, entire populator, I would say. So let's just go ahead and try to import this. So we can import this by figuring out the module name, and then we obviously have to go to the package, and the package name here is, if you see, populator machinery. And let's call it populator machinery. and we have to use this particular method from this package to actually run the controller. So let's go ahead and use that populator machinery dot run controller. Now let's go ahead and try to build this project to make sure that the autocomplete and every other Go tool is working properly. So I am going to go build. It's not going to build because we have not initialized the module. GenericHTTPPopulator. I'm going to push everything to my GitHub account, so you would be able to get the source code, etc. everything. Okay, it's lib volume populator. I think I am doing something wrong, but let's just figure it out. Okay, so do I have a typo here? Let's see. Okay, I'm going to pause. Okay, alright. So yeah, I think I was confused. The directory name between the directory name and the package name here. So this seems to be working, and now we are actually able to build the project here, and now it's complaining about compilation issues. So let's go ahead and try to fix them. So if you see here, RunController is actually expecting master URL, kubeconfig, image name. Again, we know about this image name. This HTTP endpoint and metrics path are actually the endpoint and the resource path where basically metrics for this controller is going to be available. We don't want that for now. Maybe in future we can implement that, but we don't want any metrics to be exposed, so we don't need them as of now. Namespace, we know about namespace. This namespace is the namespace where populated pod is going to get created. Prefix is actually, so what happens is, if we go back the diagram once again, in this particular diagram we can see that this controller actually creates a PVC, which eventually creates a PV. So that PV is going to have some annotations, let's say, and ideally annotations contain a prefix. Format of annotation contains a prefix, and this is the same prefix that can be configured using this prefix string here. GK is the group kind of our populator that we are going to introduce. And I think we know about this because this controller needs to know which particular populator it is running for. I think that's pretty kind of obvious, I would say. GVR is group version resource for the same populator that we are going to register. Mount path here is the mount path. If you go to the diagram once again, that mount path actually configures in this particular populator pod, where exactly this PVC is going to get mounted. Does that make sense? So if for mount path, if I configure, let's say /mnt/volume, in that particular case, this PVC is going to get mounted in this particular pod at this particular location. So if I have to write some data into the PVC using populator pod, we have to write that data into this particular location, that is mount volume. Does that make sense? So yeah, if I try to summarize, mount path here basically configures where exactly in populator pod the PVC is going to get mounted, because that is where you have to write your data, that is where you have to populate your data. Device path, same thing, but in case of block mode volumes, I would say. This is for file based volumes, this is for block based volumes. I hope this one of the most important things is populator args here. So if you see, if you remember, this populator is going to get created by API machinery, and this is going to be a pod, and pods can have arguments. So if the application that is running inside a pod expects some arguments, those arguments can be configured by pods args field. So those are things that can be configured using populator args field here. So let's go ahead and try to call this. We don't actually need to configure master URL and kubeconfig because we are running inside the Kubernetes cluster, and when you are running inside the Kubernetes cluster, when your application is running inside the Kubernetes cluster, you don't necessarily have to configure these. So I'm not going to configure either master URL or kubeconfig. For image name, I'm going to configure image. For HTTP endpoint, again, like I said, we are not configuring anything. We don't want any metrics to be exposed. Namespace is the namespace that we have here. Prefix is going to be, let's go ahead and try to create a prefix. So const, and then prefix is going to be k8s.viveksingh.dev, and let's pass that prefix here. And then schema.groupKind and schema.groupVersionResource. So group kind is going to be schema.groupKind, and then GVR is going to be schema.groupVersionResource. So GK and then GVR, and then mount path. So let's configure the mount path as well. Let's say we want the PVC to be mounted at /mnt/wall. Mount path, and device path is empty because in this particular video we are just going to focus on the file system mode based volumes. And then populator arg, like I said, this is the most important piece here, and populator arg is going to be, let's create a new function for the populator arg. So func populator args, and this is going to be of the same signature that we have here. Okay, and we can refer to this function from here. I hope this makes sense. So what's going to happen is, if we go ahead and try to look into this diagram once again, controller is going to run. It's going to make sure that it listens for PVC resources for a specific, and that too for a specific volume populator. If it finds that PVC, it's going to create the populator pod, And that populator pod, if you see here, now this populator pod cannot run in controller mode, because if we run this populator pod in controller mode, it's going to run the controller again, and that we don't actually want that. So while creating this pod, we have to pass an argument to our application. If you see here, our application expects an argument or a flag called mode. So now we have to run the same application, the same image, but with mode equals to populate. So mode equals to populate is one example of the argument that this particular pod needs. Another example is this pod actually also needs the URI that it has to download the data from. So let's go ahead, and both of these things are with controller, I would say. So controller knows about the arguments by calling this populator args function, and controller also knows about the URI because controller knows about the volume populator instance that has been referred. So controller knows about the URI because controller knows about this particular populator. Controller knows about this particular populator because we have referred that in this particular PVC. So I hope that makes sense. And controller is going to call the populator args. So to figure out the populator args here, if you see here, it calls the function with two arguments called bool. One is bool and one is unstructured. So b here specifies if the volume is in block mode, and u is the populator instance. So now if we convert u to this particular resource, we can easily figure out the URI, and that URI needs to be passed to this particular populator arg. So let's go ahead and try to basically implement this populator arg here. So what we need to do is, I think video is getting very lengthy, so it has already been 46 minutes. I think we can go ahead. Yeah, let's do this. So under populator args, like I said, we can this u is actually the resource, the populator resource that controller was called with, and we have to convert it to our concrete type here to make sure that we can get the URI. So to do that, we have to create a struct type generic HTTP populator struct. I'm just making sure that we don't have a typo, and this is a Kubernetes resource, so we can refer any Kubernetes resource to specify how do they actually look like. So type pod struct, so it's going to have type meta, obviously, and it's also going to have the object meta, let's import this particular meta v1 package. Okay, and it also has spec, and spec is, let's say, of type generic volume populator spec, and it's going to look like this. And spec just has URI here. So URI, and it's going to be string, and the tag is going to be URI. I hope this makes sense, because here is the thing, we need to do this because controller calls our populator with the populator instance, and controller calls basically the populator that we have written needs to know about the URI, and this is going to know about URI when we call this populator with the URI as an argument, right? So we are going to call the same binary with mode equals to populate, and then URI equals to the URI that we are going to figure out here. And to figure out the URI, we can leverage the resource that is passed here. So now let's just go ahead and try to, first of all, if B is false, we don't support that, but let's not handle that. So I am going to use another package to basically convert this to this particular typed resource. And I think I have already talked about it when I talked about dynamic clients, but if not, this is how we do it. So we can use API Machinery's runtime package and default unstructured converter dot from unstructured and u dot unstructured content, and we want to basically convert this u into a resource of type GenericHTTPPopulator. So GenericHTTPPopulator, and then let's call it GHP. And this returns an error. So error colon equals to this. If error is not equals to nil, in that case, let's just log that failed converting unstructured to generic HTTP populator, and the error is this. So here, once we have the generic HTTP populator, what we can do is, if you see here, it expects, we can return the args and we can return the error. So let's create a variable called args and string, and we are going to append if you remember, we have to now, so this arg is for the populator that is going to get created. So even though we are going to use the same binary, but we have to specify that we want to use that in the populator mode, right? So po, let's make sure that we don't make another typo here. So populator, and it also needs the URI because our application expects URI. So where URI is going to be a string, and then flag dot string var name is going to be URI, URI for the content of the volume. URI equals to %s and the URI is going to be ghp.spec.uri. I hope this makes sense. So now what we have done is we have almost written our controller. This is everything that we need to run a controller, because if you see here, RunController is actually going to start the controller. It would listen for all the PVC resources, and it would create this particular populator pod with this particular image and this particular argument. I hope that makes sense. So now controller is done. What happens when the populator pod is created with the image or with this particular application, right? So if the same application is created with mode as populator, if you see here, this particular case is going to get called. So this particular the code that we run here the code that we run or write here is going to get called from populator pod, or this is the code of populator pod in a way. So from populator pod we know that PVC is mounted at mount path. We know about this because we have passed mount path here. So all we have to do is we have to write some data into this mount path, and that some data is actually the content from this URI. So let's create another function called populate, and populate is going to get called with URI. So func populate, and then URI is going to be string. And what we have to do now is we have to, but I'm seeing that we have not actually implemented this. This would be a blunder if we forgot about it. So let's go ahead and try to do that. So group of our volume populator is gates.vivek dot.dev, and kind is HTTP volume generic HTTP populator. So group is going to be gk.group, and version is going to be again v1 alpha 1. And resource is going to be generic HTTP populators. I hope this makes sense. So now under populate, what we have to do is, if I try to again explain, we have an HTTP endpoint, and we have to download the content from this particular HTTP endpoint, and we have to write the data into volume. And we know that there is a volume mounted at a particular location, and we can figure out that from mount path. So all we have to do now here is we have to write the data at mount path slash let's create the file name to be readme.md. So we have to just make an HTTP request to this particular endpoint, get some bytes, write those bytes to this particular location, and we are done. So let's go ahead and try to do that. So if URI is equals to empty, in that case log dot printf URI is empty, URI can not be empty, panic I would say. And once we have the URI, let's make an HTTP request. So HTTP dot new request, the method is going to be get. So HTTP dot method get, URL is going to be the URL that we have here. I am not really sure why I named URI, maybe because I wanted to be a bit more specific, but URL would have been fine. So the new request is going to get us the request and error. So request :error equals to this. If error is not equals to nil, in that case we are going to just log it, printf failed creating, don't mind the typos please, creating new request, error is %s and panic. Okay, so now that we have request, what we have to do is we have to do two things: get the data, download the data from this request, and create a directory and create a file, basically this file, and write the data. So let's go ahead and create the file first. So os dot create, and the name is going to be path dot join, and we know that we want to write the data at mount path and then file name. What is the file name? We will have to figure out the file name. So let's figure out the file name. So file name equals to path.base and then request dot so we have the HTTP request, and from request we can figure out the URL dot path, I think. So relative paths omit leading hash. So we just need the path from the URL. So, and you don't have to follow this. You can just Google how to figure out the file name. Let's say from a URL, you would be able to do that. So request dot URL dot path, and now this has the file name, and let's use the file name here. And dot create actually returns file and error. So if error is not equals to nil, in that case we are going to log fail to create file and then panic. So now we have created a file, we have created a request. Let's download the data and write that into the file. So http.defaultClient.do, and this accepts a request. So this is actually going to make that HTTP request, and it returns response and error. So response and error, if error is not equals to nil, in that case we can do the same thing, printf failed making, we have some inconsistency here, capital and smalls, but yeah, failed making the request, and error is this. We could have returned error from this function. We would just have in that case we would just have to write panic once, but yeah, I think it can be improved always. So errors dot new error, and then we have response, we have file. Let's write that into that file. So f dot, first let's read the bytes. So data io dot read all, and response dot body, it gets us, read all gets us by slice of byte and error. So data error equals to this. If error is not equals to nil, in that case fmt dot printf fail to read data from response and then panic. We have data, we have file, let's write the data into file. So write data, and it returns the bytes that have been written, and error, we don't care about the number of bytes that have been written, we just care about the error. So if error is not equals to nil, in that case log dot printf failed writing data to file and then panic. And if we are here, it simply means that the file was written successfully. So populated successfully. I think we are almost done, I would say. So let's go ahead and try to build this project to see what exactly happens. Okay, so there doesn't seem to be an issue, and we obviously also need a Docker file to containerize this. So let's go ahead and try to build a file here. Called Docker file, and we are going to use Alpine, and we are going to copy the binary. Binary is called GenericHTTPPopulator. So GenericHTTPPopulator, and the destination is going to be user local bin, and then we are just going to run that binary. So user local bin and then GenericHTTPPopulator. I hope this makes sense. There are better ways to do this, obviously, but yeah, we are not focusing on that. So let's go ahead and try to build the binary again, but we are going to build it using another way by specifying some flags so that our binary can run on Alpine. We are basically making sure that it doesn't need a lot of dependencies to run. Very simply, we can say that because we want to run that in Alpine. So building the binary again. And once the binary is built, we are going to build the container image. It's taking some time, and okay, maybe I did not hit enter, I'm not really sure. So once that is done, we would like to build the container image called Vivek Singh GGITS, and then generic HTTP populator, and the tag is going to be, let's say, 0.1.0. So generic HTTP populator 0.1.0. I'm going to build the binary once again just to be sure. And then we are going to build the image. We'll also need a manifest to deploy this container image, to deploy this populator. So we are going to do that as well. Let's go ahead and quickly create a deployment manifest. So create deployment. We are going to call it, let's say, controller. The image is going to be this image, and we just want to generate the manifest in manifests and controller deploy.yaml. So we should have controller deploy here, and we have the correct image here. If you remember, the binary has been built. I'm running the docker build command to actually build the image. The image is being built now, and it has been built. So let's just run this image to make sure that the binary is able to run actually. If you see here, mode is not supported because we have run the application, but we have not specified any mode. That is the reason I said we have to specify the args here. So, and meanwhile, I will push this image. And this is how the args to our application can be specified under a pod. So if you just Google pod args example Kubernetes, you should be able to see some examples. So if you see here, this is how we specify the arguments. So arguments are actually slice of string, and this is how they can be specified. But they are slice of string. So we are going to use this particular way of doing that. So hyphen mode is going to be, and this is how we specify arguments to a Go application, let's say. So hyphen mode is going to be controller by default, because we want to run our application in controller mode by default. And then the other argument that controller needs is, it obviously needs image. So hyphen image is going to be the same image that we have here. And then it also needs the namespace. So namespace is going to be namespace, and namespace is going to be controller. And we are going to, let's say, install it in controller namespace. I hope this makes sense. Now, if I create this controller right away, it's not actually going to work, and the reason is if you see here, the run controller that we have written here, and we have also talked about it, it's going to listen for all the PVC resources. It's also going to listen for, or it should also be able to basically list or read these resources, generic HTTP populator resources. So we have to provide all those permissions to this particular resource, to this particular controller. Now, since we have not written this controller, we don't exactly know what are all the permissions that are required by this controller. That is the reason we are going to refer to the same library here. So, and it has an example where it specifies what are all the resources, what are all the RBAC permissions that are required. So if you see here, these are all the permissions that are required. So we don't need this because we have created the deployment. We are just going to copy everything from here. And I'm going to explain it. It's going to make sense. Don't worry about that. So controller deploy. So what's happening is we are creating a namespace called controller, because that is where we are going to deploy our application. And to make sure that controller has proper privileges, we are creating a service account name called GHP-account, and it's going to be created in namespace controller. And then after creating the service account, this is the service account that is going to be used by our controller. We are creating a cluster role where we configure all the roles that should be assigned, that our controller should has. So we are going to call it GHP-role. If you see here, this has access to persistent volumes, claims, pods, events, storage classes, and this also needs access to our populator that we have here. So let's go ahead and try to give that as well. So k8s.viveksingh.dev, and the resources are generic HTTP populators, and now under cluster role binding, if you see here, let's call it GHP binding. GHP binding service account is GHP service account. I think this is the service account name. Yeah, this is the service account name. So GHP account namespace is going to be controller, and cluster role is going to be the name of the cluster role. So the name of the cluster role is GHP-role. So GHP-role. So we have created a cluster role. We have created a cluster role binding to bind that cluster role with this particular service account. And we are going to refer this service account from our controller pod. I hope this also makes sense. So let's go ahead and refer this GHP account from our deployment. So service account name is going to be GHP account. And we are good, I would say. So let's get PVC from default namespace. Let's delete this PVC. So we have deleted the PVC, and now we are going to create the create the controller in controller namespace. So controller deploy.yaml, and if you see here, it has been the controller has been created. Now what we are going to do is now we are going to create the PVC, and it's going to all those things that we have talked about. But let me try to summarize what are all the things that are going to happen as soon as we create the PVC. So we are going to create the PVC in the application namespace. And as soon as we create the PVC in the application namespace, our controller is running in the controller namespace, and it's going to listen to that PVC, creation of that PVC, and that is the reason we have created that cluster rule and cluster rule binding, if you remember, and to make sure that this controller has access to PVC and PV resources, etc. We need cluster rule and cluster rule binding because this controller needs to look for the PVC resources on all the namespaces. So there are chances that there is this application namespace where we created the PVC resource specifying the same dataSourceRef, right? So this controller needs access to this PVC as well. That is the reason we are creating cluster rule binding resources. This PVC would figure out the arguments, and this also has the image, and then it's going to call the populated pod, and this pod is going to get created in controller namespace that we are going to see in just a second. And that controller namespace, we would also be able to see that this PVC resource that gets created, and this controller would write the data into PVC, and then basically once the write succeeds, this temporary PVC is going to get deleted, and the PV would be bound to the application or user created PVC. So let's go ahead and try to do that. I'm also going to follow the logs of controller namespace. So logs-n controller and controller-f. So if you see here, it says that it's starting the controller, and it also says that it is using in cluster config that we want to do. So now let's see if things are actually going to work or not. So we would also try to look into the logs of this new pod that gets created, because that is the pod where all of the logs that we have added are going to get created. So create -f, and let's create the PVC. So this is the, let's see. We don't see an error in the, if you see here, we see a populate pod, right? We see a populate pod here, we see a PVC created here, and that is the most important thing that I wanted to show here. It's called prime something, and it has been completed, right? It has been completed, a PVC was created, and now this PVC is going to get deleted as well in just a second, let's say. So if you see here, PVC was created, pod was created, and now the PV that was created has been bound to the PVC that we have created in application namespace. So now let's get PVC from application namespace, and if you see here, PVC has been bound. And if we look into the PV called this -o YAML, if you see here, this is the annotation that I talked about initially. Since we have configured prefix here, this is the prefix that is used in the annotation in the persistent volume that is created. So k8s.vxing.dev populated from, and then this is the populator that was actually used. And I think things worked perfectly fine, but we would not know until and unless we consume this PVC, right? So we consume this PVC and make sure that the file, this particular file is present in that PVC. So let's go ahead and try to create a pod to do exactly that. So kubectl run nginx, image is going to be nginx. This is a test pod. You can use any image that you want to, and I'm going to just try and create the client, create the manifest -o YAML pod, or let's say checker.yaml. So now we should have a checker.yaml here. We are going to create we are going to create this pod, but before doing that, we want to verify that this particular claim has the data of the README. So let's mount that volume. So volumes name is going to be, let's say default volume or something like that, and this is a persistent volume claim, and claim name is my claim, and we want to mount that this volume at the mount path. We can mount it anywhere, and then we can check the things. So let's mount it at mount slash check. Now let's go ahead and try to create this checker pod. So kubectl create -f manifests and then checker.yaml. It should not have taken this much of a time, but yeah, let's wait for this particular pod to get created. It seems like I have some problem with the network. I'm not really sure. Okay, this is weird. Okay, I am going to fix this. And then I'll be back. I'll pause the recording and then I'll be back. Okay, I did not actually have to do anything. It worked the second time, so it failed, and then when I ran kubectl get ns, it actually worked. So let's go ahead and try to create the checker pod. So now if you see here, the pod has been created, and let's wait for it to be running, and then we are going to exec into this pod to verify that our file has been created. So exec into the pod in default namespace called nginx, get bash, and cd into mount check, and here we go. If you see here, this is what we have been actually trying to implement, and this is the same readme file. This is the same readme file that we wanted to populate our volume with. So yeah, I hope this makes sense. If you have any question, don't hesitate to reach out to me, and we would be I would be more than happy to basically answer those questions. But yeah, I mean, you can stop watching the video, but I will try to summarize this again. This is the controller that is doing the most of the heavy lifting. It listens for the PVC resources, and then it actually creates a PVC in the controller namespace, and then populates that PVC with some data. And once the population has happened, the owner or the claim of this PVC is changed to the application PVC, and then it gets to bound state. So after this PV's claim has been changed to this PVC, from this PV it gets to bound, and then we can check the data has been written. But to actually write the data, this controller runs an application that is responsible to generate the data. This application can be written separately, but we have the same binary that does that. And this application is run using some argument, and we have the privilege to basically configure those arguments. In some cases, let's say if the populator needs more than one argument to populate the data, we have all the privilege. Let's say we have that capability to configure that argument, and we called this populator pod with two arguments. One was actually the mode, where the mode in which this application needs to be run, and the another option was the URI. So because we need to know where exactly do we want to download the data from, and because this controller needs to listen to PVC resources, it has to generate the event, etc. It needs access to all those things. I hope that makes sense. that is pretty much it that I wanted to talk about. I would make sure that I push this to a GitHub repo. I will link the GitHub repo. I will link the GitHub repo in the description. You can check that out. And let's look into the events of PVC to see if okay. So if you see here, assuming an external populator will provision the volume. I think what we can do is this can be improved. This can be improved to actually make sure that once the population has happened, if you want to contribute to this project, I would be more than happy to accept the contributions. And what we can do is from main.go, after the population has happened, we can update an event into the PVC. We can update an event into the PVC stating that the population was successful. I think that would be really cool. If you want to do that, you can do that. I would be more than happy to help you do that. That is pretty much it. I really appreciate you watching the video. Like, share and subscribe. I will see you in the next one. Thank you so much.